So in this video, we are just going to detailedly discuss about the stack operations inside the microcontroller. That is, we are just going to understand how the data is manipulated in and out of the stack of the microcontroller. There are only two different operations possible inside the stack. One is the push, which saves value into the stack, and other one is pop, which retrieves the value from the stack. As I said, stack is a last in first out storage region, so you can only pop out the last stored value. You cannot pop out last one before stored value out of the stack. And let's consider these are all the basic registers available in the microcontroller, that is ARM Cortex-M processor, starting from R0 till R15. And these are all the values inside the registers. R0 we have 7, R1 we have 3, etc. And just consider this is the stack, and on the bottom you can see this is the stack pointer pointing to the top of the stack or the lowest address of the stack. And as we discussed in the previous video, I am just going to consider only 4096 bytes of stack inside the RAM region, starting from 20000000 till 200000FFF. Now I am just going to perform push of R2. Now we have the R2 value to be 5 right over here. And when I try to push this R2 value to the stack, what happens is it will actually store the data in the top of the stack, and then sequentially the stack pointer moves to the next consequent address in the stack area. And as I mentioned, ARM Cortex-M has 32 bits data address. So the stack pointer actually moves the next fourth byte. For example, the address is subtracted by 4 and the stack pointer moves to that. And now when I try to push the R3 data onto the stack, when I give push of R3, the R3 data right over here is integer 6. The integer 6 is stored and the stack pointer moves to the next consequent fourth byte, since the ARM Cortex-M processor is processing with 32-bit address. And when I try to push R4, R4 is having the data 9. The R4 9 will be stored on the top of the stack, and the stack pointer will be moved further to the next fourth bit, subtracting the 4 bytes. And when I try to perform R5, similarly the R5 value 1 is moved to the top of the stack, and the stack pointer will be furthered moved to the fourth byte of the stack area. This is how a push instruction works in stack operation. That is, this is how you can push the data onto the stack. It is like stacking the books in a library. You cannot take the book that is available in the last shelf or one below the shelf. So you can only pick the book at the top of the shelf, and you cannot retrieve the book in the middle of the shelf unless you can pick all the books out of the shelf. So just consider book stacked in the library shelf as the stack of the microcontroller. And now let's try to understand the pop operation. Pop is nothing out, pushing out the data from stack. And as I mentioned, stack is a last in first out temporary region. So it works in the principle of last in first out. So here last in data right over here is R5. So when you give like pop of R0, this data will be directly taken and stored inside the R0 register. That's it. This is what happens. Now you can see when I execute the command pop R0, this is what happens. The data in the first position of the stack will be picked and it will be placed in the registers mentioned in the pop instruction. And further, the stack pointer is decremented by 4 bytes. As the inverse of operation for push, this happens. That's all. I hope you understood push and pop operations in stack, and stack is always operating in the method of last in, first out. I hope you understood how a basic operations or data manipulations happens inside the stack using push and pop operations in this particular video. See you in the next video. Thanks for watching.